Good morning, friend. Once again, this session is towards more into AVP, and even previously also this previous session was on AVP, where I showed you on the Wireshark traces like how many AVPs we are having in that particular request, which I took. I think it was CCR, credit control request, and answer. Okay, so now I will show you properly on the slides as well as both practically like how these AVPs helps in giving some information as a diameter message. Okay, so basically, as I told previously, like actual information is inside the AVP only. That's the reason, or we say here is AVPs are the method of encapsulating information relevant to the diameter message. Now encapsulation, what does it means? Like encapsulating means I'm binding my information inside a packet in such a way that when I explore it, means when I receive it and when I open the packet, it would give me a relevant information. So here the grouping of the AVPs, the representation of an AVP with that AVP code, AVP length, then AVP information, all those things comes as a encapsulation. Means this is the encapsulation technique. So the IETF, who has designed this diameter protocol, who has acted as a governing body of this diameter protocol, is actually the one who has standardized the method of AVPs representation, encapsulating them. Okay, so it's very simple. So as I told in a previous lecture, that it's not like only one AVP is there per diameter message. It could be multiple AVPs, but all these AVPs will represent to one session ID. Now in the later slides I will explain you what is the difference between a connection and a session, because it both are not the same thing. Session is different thing, it comes in a logical way, but the connection is a different thing which comes in a physical way. Okay, suppose I want to talk to my friend. Okay, so I have to build a physical connection with him in order to speak something. So what I will speak with him or what I will give to him is a logical thing. Okay, but before that I have to make a dedicated connection with him. Either that connection could be wired, wireless, or I should go his home and meet him physically, then send this message. So it all depends, but the difference, you just try to understand difference, that one is physical, one is logical. Okay, so similar way, a diameter message passing is a logical thing, but how the two nodes are connected and how that message floats from one node and then flows towards the other node is the physical part. Okay, so don't get confused, I will explain it in the later slide, but let's now continue with the AVP. So all these AVPs you can see here, a sample I have attached, and I have also shown you through the diameter TCP dump yesterday, like how these diameter AVPs are shown. So again, like see, all these diameter messages are there. Then this is the request message and this is the answer message. And kindly note that request message will always have all the messages that the client wants to send to server, and in return when server replies, it replies with the answer message. So this one is the answer message. Let me, okay, no, I cannot use here the pointer, but I hope you can see this. I have pointed on the answer message. Okay, so answer message will always have one AVP which is common in all answer message, that is the result code. So if I open the result code it is giving me diameter success, which means that whatever request message I have sent to this server, the server has read it all. Okay, and it is satisfied that yes, the the message is correctly delivered everything. So that's why server always respond with the answer message saying that diameter success. If the diameter is not success, suppose, then you will always find a relevant error message through which you can find out like what kind of error it is. So I will also explain on that part the error response codes of diameter, but not right now. Okay, so you just understand that one is request message, one is answer message. Request message is having all the input parameters, and in turn the answer message will always give some output as well as the response code, which is success or failure. Okay, so this way you can see all the AVPs are there, we discussed in the previous session. So now let's move forward. Okay, so this is a very simple diameter call flow. It's a basic protocol call flow. Okay, so as I told, I think previously also I told, like this is the basic message which flows. First is the capability exchange. So this is the message when diameter client A talks to diameter server B and sends all the capabilities which it is having in him, and in turn it expects diameter server to give a success message. So if diameter server gives a success message, means both the nodes are on the same node, means they can easily talk to each other. Okay, similarly, after once this message is created, means our physical connection has been created, and then there is a device watchdog request, DWR. So device watchdog is related to the heartbeat checking, means if the client wants to continuously check with the server whether server is alive or not, so it will keep on sending this DWR message. It's a very thin message, very light message, so it will just give a response code success, which means that both the nodes are alive. Okay, then the last message is the DPR, which stands for disconnect peer request. So it is basically when client wants to disconnect the physical connections with the diameter server, okay, on an application level. Okay, so this is the, I think this is clear. Okay, so let's go to the next one. Okay, now this is also one of the important things. So as I told you about the various command codes, so every message in a diameter protocol has a command code. Okay, why command code? Because it is easy for us to search in a diameter traces, like what all request goes. Okay, what kind of request, means is it a capability request, it's a watchdog device request, it's a credit control request, or whatever request it is. So here I have listed few of the command codes. Like we have capability exchange request, which has diameter code 257, device watchdog which has code 280, credit control request 272, similarly disconnect peer request 282, and session termination request 275. Okay, so guys, if you have noticed, like what is the you might be thinking, what is the difference between disconnect peer request and session termination request? So this is the same thing which I was explaining you before, that there is a difference between connection and a session. So if I am breaking a connection, then this request will be exchanged. Which one? Disconnect peer request, because I am breaking a connection. But on top of my connection comes is the session. So if I am breaking the connection session first, then connection, then on disconnecting the session, the request that will be exchanged will be STR, session termination request. So here I think the first example is self-explained, like you can see difference in the command itself. Okay, so let's move forward. Now AVP also has a structure. I even showed you in my previous lecture, but again I have updated this slide just to show you a high level picture of how AVP looks like. So you by now you all knows what is the structure of diameter packet, like version, message length, command code, application ID, hop by hop, and end-to-end identifier. Now comes the AVP, which stand for attribute value pair. So AVP itself has some this nomenclature, so which is consists of AVP code, AVP flag, AVP length, and vendor ID. And out of these, vendor ID is optional. Why vendor ID is there and why it is optional is, like, you know, as I told that diameter is a base protocol, and all the industries, okay, all the application providers, they are creating their application using this diameter base protocol. So IETF has given an option to those vendors that if they want to add their own AVPs, okay, then they have to provide this vendor ID as an optional parameter, so that the server can understand that, okay, this is a additional vendor IP. And I will tell you one more thing, like if any vendor has introduced his own vendor vendor AVPs, then it's not easy to decode that TCP dump. Even I will show you my TCP dump, wherein I will show you like there is some special vendor ID introduced by some other vendor, and I am opening that TCP dump, but it will not show me anything, because to decode that vendor messages I need to have their own capability enabled in the varchar tool. Okay, but what the varchar which I am using currently, it's a very generic one, and I cannot see those AVPs in it. But what I can know is that yes, this is a vendor ID. That's why it is not opening in this normal varchar. Whereas if I go into that company, take their tool and open the TCP dump on their tool, definitely it will be visible. Okay, so we'll not go deeper into the vendor ID part, but I will just show you like how AVP code, how AVP structure is there. So if I open the TCP dump, you will see AVP code here, which is the 263 session ID. So even in the diameter command code, there is a lower thing which is AVP. AVP also has an AVP code. Okay, so here the AVP code is 263. So session ID has a AVP code 263. Okay, similarly, we have flags for AVP. Again, those flags are vendor specific flags. This mandatory, protected, reserved. So you can see the description of these flags in the this IETF diameter based protocol 6733 RFC. Okay, but on a higher note, you can see it looks like this. Okay, then we have again AVP length, and then we have the actual session ID information, which is there. Okay, and this vendor ID is optional, and you can see that vendor ID here I have shown as AVP vendor ID 3GPP 10415. So that particular vendor, okay, has a ID 10415. Suppose I have another vendor, like let's say X has ID 10415, and we have another vendor Y which is having ID, let's say 11500. Okay, so it differs from vendor to vendor, but other than vendor ID things, everything is neutral and it will be same as per the 3GPP RFC. Okay, so let's go to the next slide. We have grouped AVPs also, so I will show you, no need to worry, but I'll show you what are grouped AVPs. But okay, fine, let's go to the Wireshark quickly. So these are all AVPs as I explained you, but let's see where is the grouped AVP. Okay, so I will open another TCP dump. Now see this AVP. If I open this AVP charging rule install. Okay, no, this is not a grouped AVP. I just want to show you a better example. Okay, so okay, I'm not able to search right now group AVPs, but you can understand that multiple AVPs inside one AVP is called as group AVPs. Okay, and it's nothing like, means it's not a very different things to understand. It's very simple. So whenever I'll get it, I'll definitely show you the group AVP part. Right now I'm not getting it so anywhere, but yes, but you can just understand, like see, we have a AVP called ANGW address, and inside that we have two different AVPs. Okay, AVP GW address and AVP. Okay, no, here this is also not grouped AVP because only one AVP is inside it. This is a nested AVP but not a grouped AVP, but no need to worry about. Let's move forward. Okay, so guys, from next lecture onwards, I will not tell you about diameter because every basic thing about diameter is covered, and from next session onwards I will focus more into the telecom, because this diameter protocol, as of now what I remember, is like it is majorly used in telecom only. So it's not a HTTP kind of protocol that is visible to every user. That's why reason many of my viewers will not be able to understand my lecture series, because it's not made for them. But even if they are interested, they want to step into the telecom in the BSS domain, means business support subsystem, then this understanding this protocol will be better for them. So this is a protocol which is installed on our machines, and machines communicate to another machine, and both of them should be on diameter. And we have when many vendors have developed many applications on top of the diameter based protocol, which are again standardized by some other governing bodies, which is 3GPP. And this is a diagram on a very high note which I'm showing you, consists of all different applications which works with different systems. So if you see here, I have for policy I have an application which is GX, which is RX, which is S9 and ST. Each and every application is slightly different from each other. Okay, and then we have charging, GY, GZ, SY, and for subscriber info we have SH. And in the application, on a very high note, I have drawn all the boxes and the applications between them. So generally in telecom we call it as interfaces, but I call it as application and interfaces both, because it is easy for my viewers, for my friends to understand what I'm saying. So guys, I will continue this thing from my next lecture onwards, because we are falling short of time. Okay, so 15 minutes videos ends up here. Thank you so much, and keep supporting, and I will keep you sharing all the good things. Please comment below my videos to let me know what is the difficulty in understanding, or what you want me to improve in my videos, and I will definitely come back to you. Thank you so much guys. Thank you.